Hello everybody and welcome back to the second part of Indices, Surds and Logarithms. Today we're going to be doing logarithms. So first of all, let's look at what log is. So log ay is equals to x. What does this mean? This means that what power can I apply to a that it makes the answer y. So this is what we're basically finding. X is this, a to the power x is equals to y, and you can see that this is reflected here when we write y is equals to a to the power x. A shortcut to remember this is that the power here goes over here and it goes underneath the variable here, and the variable becomes the power over here. And similarly, this can be done in the vice versa, that you can put a log over here with y, and the x can come down from the power and the a can come down over here from being the variable having the power x. So the log function is basically to find what power do we have to apply to make it a equal to y. Okay, so let's look at a question. Log x 8 is equals to 3 upon 2, and we have to find x. So simply we'll take x there. So x to the power 3 upon 2 is equals to 8. X to the power root 2 into 3, 8. We can put a cube root on both sides. This will cancel with this, and this will give us 2. So square root of x will give us 2. We will square both sides, and x is equals to 4. So we get x as 4. Okay, so let's take a look at some other types of logs. First of all, we have a common log, which is a log with base 10. So basically we're finding what power do we give to 10 to make it equal to x in this case. So the syntax of writing that is lgx. So if it is written like that, you should assume that it is log to the base 10. Okay, this is the same thing. Okay, now the second type of log is a natural logarithm, which has e as its base. Now e is a number which you don't have to memorize, but just remember that it is written as ln. So log to the base e is equal to ln. Okay, this is again the same thing, that we have to find the power given to e that will make it equal to x. Okay, so these are certain rules you will have to abide with. So if both the base and the number are same, that means that it will be equal to 1. So if I write log 10, that means that I have to put the power 1 on 10 to make it equal to 10. Similarly, if a log exists, its a value has to be greater than 0, its b value has to be greater than 0. If log a 1 is equals to 0, that means that I have to put the power 0 on a to make it equal to 1. So this is what it basically represents. Just remember that whenever there is 1, it will be equal to 0, and these both numbers should be greater than 0. If they are less than or equal to 0, the result will not work out. And also, for the log to be defined, a cannot be equals to 1. Okay, so like in indices and surds, log has certain laws. To change the base, you can take a common base and make it like this. So log a to the base a b can be changed into log c b upon log c a. So for example, I have log 3 4. So normally it is an easier method to take lg, so you can make it equal to lg3 4 upon lg3. Obviously this is log to the base 10. This will be simpler to solve in questions which we will encounter later. Similarly, if you have log AB, and you can reciprocate it, and you will get log BA. Okay, so the product law is that if two numbers are being multiplied in the log, you can write it separately like this. This is the actually the opposite of what we did in indices. There are two more laws: the quotient law and the power law. The quotient law is that if two numbers are being divided, they can be subtracted. Again, the opposite of what we did in indices. Then there is the power law. This is what we will use a lot. If log a to the x to the power r, we can take this r over here to write it like r log a x. Okay, now let's take a look at some logarithmic equations. So for example, we have log a m is equals to log a n. We can say that m is equals to n. So the bases have to be same for them to be equal. So in this case, we have log p2 plus log p x minus 1 is equals to 0. Let's solve this. This will become minus, and because this is minus 1, we can take it to the power over here. So this will become log p2 is equals to log p x minus 1 to the power minus 1. Okay, now we can see that the bases are same, so we can equate 2 is equals to 1 upon x minus 1 because it was inverse, so we have to reciprocate it. This will give us 2x minus 2 is equals to 1. So 2x is equals to 3 and x is equals to 3 upon 2. Okay, now in this question it says that 3 lgx minus 1 is equals to lg8. So again we will take this 3 over here to make the bases the same. So now that the bases are same, both have a base of 10 because it's lg, so we can equate this to this. So we'll take a cube root on both sides. This will give us x minus 1 is equals to 2 and x is equals to 3. So that was all from log. Do more questions of log to understand it more better. Thank you for watching. Goodbye.